Hopefully you guys can stay awake after all that food. So today we're going to talk about WebAssembly, and I'm really excited to be here to talk about it because I am obsessed with it. If you follow me on Twitter, you can probably tell because I tweet a lot about it and I advocate for it. And that's just fundamentally because I think WebAssembly is going to change the way we think of web apps, what a web app is, what it's capable of, the different features. And I think it actually is going to allow us in the future, and this is a little far future, to bridge that gap finally between the web, like a web browser, and actually a native application. So who am I? I'm Jay Phelps, and I used to be a software engineer at Netflix, but just recently I actually left Netflix to start a company with my friend Tracy called ThisDot. And what we do is we do things like support contracts for things like ArcsJS, React, Redux. We do trainings and workshops and mentorship and developer relations. So if any of this stuff is interesting and you need someone to help you, definitely reach out to us. So let's get started. What is WebAssembly? Well, it's also known as WASM, which is an abbreviation. Well, the buzzwords, I guess, would be it's an efficient, low-level bytecode for the web. But let's break this down a little bit. When I say efficient, I mean that it's fast to load and execute. It's going to be fast to load, as in sending through the internet to your browser, and then fast to actually execute. Once those bits have gotten to your browser and it's been compiled and it's running, it's actually fast. And so, like, one of the things that makes it really fast is something called streaming compilation. And this is something that JavaScript, unfortunately, it's not possible to do this on JavaScript just by the very nature of the language. And I have a little visualization to express what I mean by streaming compilation. So this is like an iPhone, like your mobile device. And let's say that we've got a WebAssembly file on the server, and that file gets sent to your browser. Well, with streaming compilation, as each piece of the WebAssembly comes across the web, we actually can compile it faster in many cases than it comes across the wire. So we're done compiling that segment. Say, like, there's a segment of the code, there's another segment, and it's compiled to machine code faster than it comes over the wire, which is super, super important because, in the last 5 or 6 years with JavaScript, there's been a huge increase in people realizing how slow it is for JavaScript itself to be parsed and compiled. So that you may have you may work really hard to get your bundle size down to like less than a megabyte or something like that, 500K, whatever. But then you look at your parse times and you're like, whoa, that's adding another whole second or what have you on your mobile device. But with WebAssembly, it can be actually parsed and compiled faster than it comes over the wire. Not in every case, but in a majority of those cases. And it does get compiled to machine code ahead of time. So because once the data comes to your browser, it has to get compiled. Why is that? Well, it's because it's a bytecode. All these different computers and mobile devices have different processors on them, right? So they have different instructions they need to run. And so you need a higher level abstraction to abstract away that. And so the bytecode is a way of essentially representing a virtual machine, a machine that doesn't actually physically exist. It's virtual. It's a fake machine. And that's WebAssembly. WebAssembly is a bytecode that then gets compiled down to your native code when you're running it in your browser. Well, what's a byte? Well, this is an example of one of the byte instructions. This is the add instruction. This is in hexadecimal on the top and then binary on the bottom. But this is not very useful just looking at this, right? You wouldn't know this was add unless you were giving the stock or something. And that's because WebAssembly is intended as a compilation target, right? You're not writing this stuff by hand. It's bytes. It's binary format. So you'll write in a higher level language, say C, Rust, or maybe in the future other languages, and that gets compiled down to this bytecode. You don't write this by hand. It's very similar in comparison to assembly code, right? You don't typically write machine code by hand. You can. So let's take, for example, this very simple C function. And even if you guys have never written any C before in your life, you can probably understand what this function does. It is for generating factorials. And it's got ints as the type definitions. But this code, if you compiled it down to WebAssembly, would look like this. This is the actual binary representation of this C code in WebAssembly. And WebAssembly is also safe and portable. Now, this is unlike normal machine code, right? Normal machine code has a lot of potential for exploits. It's also not portable, but on the safety side of things, how many people here, even if you've never written any C code, have you heard of a buffer overflow exploit? Right? It's a very common thing. Even if you don't know what it means, you know that it exists, and it's a very common, easy mistake to make, even in languages like C, C++, stuff like that. But with WebAssembly, those classes of exploits are not possible. Even though you're taking C and C++, you can compile that down to WebAssembly, and you will not be able to have those type of exploits. Now, that doesn't mean your app still won't function correctly if you incorrectly overflow your buffer, right? So if you overflow the buffer, weird things, undefined behavior can start happening, but you'll never be able to, so an attacker will never be able to use that and jump to their own code. And that's for very complex reasons, but fundamentally, the code, and the actual executable code and the code that you use for like storing state and any type of memory are completely isolated and separated in WebAssembly. They're not interacting. And you need to be very deliberate ahead of time to say, I want to be able to jump to this function, this arbitrary function. So, and that's just like JavaScript, right? If you have JavaScript and you say prompt, you call prompt, which is similar to alert, except for a person can enter any input, you don't have to worry about the fact that people could type JavaScript functions in there and it's going to execute, unless you pipe that into eval, which, of course, you're circumventing those protections. But there's a really good quote that kind of touches on how this whole thing works. It's by Ben Smith on the Chrome team. He says that WebAssembly is like the shortcut to your JavaScript engine's optimizer. And that's because WebAssembly was designed with JavaScript in mind, and especially for these browsers to be able to implement this. It actually uses the same underlying virtual machine that these modern JavaScript VMs do. It reuses that exact same thing. But there's a problem with this quote, and it's that it kind of infers a question that people commonly ask, and that's, is this going to kill JavaScript? Like if we're shortcutting to that, why wouldn't I just like compile my JavaScript straight to that? Compile it to WebAssembly, shortcut that, and the answer to this is no. This is not going to kill JavaScript, and you're not going to compile your JavaScript to this. That's what the browser vendors say. Now I'm going to go out on a limb in a little bit and make a little bit of a prediction. Kill, I think, is a very strong word because it implies JavaScript completely just disappears. But I do really personally feel that WebAssembly will open up a new renaissance of languages, and maybe, just maybe, in 5 to 10 years from now, all of you people won't be writing JavaScript. You'll be writing some other language. You'll be writing Reason or Elm or maybe C# or PHP, whatever it is, you will be able to target WebAssembly, and it really just opens up that choice. And I think, actually, that I don't think the existing languages, I think, are going to be dominant. I think a language designed specifically for the web, like Reason or Elm or Dart, I think are the ones that really are going to take off and rocket. So going back to that question about compiling to WebAssembly, JavaScript to WebAssembly, the reason why that's not a doable thing is JavaScript is such an extremely dynamic language. Extremely dynamic. And I wish I had time to show you some examples of that, but I was cutting down some slides, and this made the chopping block. But really shortly, you can do all sorts of really crazy things with JavaScript, and that are very dynamic. And while you could compile that to WebAssembly, if you did so, it would be a lot slower than just writing JavaScript, because JavaScript virtual machines these days are very, very fast, and they're very, very clever. They know and learn JavaScript, and it's pretty hard to compete with that. Now, that's not to say that you won't be able to write a subset of JavaScript, right, without all of those super crazy dynamic features and still get 90% of that features. But so for the V1 of WebAssembly, it's best suited to languages like C++ and Rust, and that's probably why a majority of you in this room probably haven't started writing writing code that compiles to WebAssembly, because the majority of us don't write that in our day job. We don't write C++ or Rust, at least right now. But other languages are a stated goal, and they're coming soon. Languages like Java or OCaml, or these new languages like I was speaking about, like Reason, which I'm really excited about personally. So I'll give you an example of that. TurboScript. And with WebAssembly, this language was designed specifically around the WebAssembly use case. So take a look at this. I bet most of you actually think this looks really familiar. What does this look like? It looks like TypeScript. And then syntactically, it is identical to TypeScript. They actually even use the TypeScript parser because syntactically it is the same. Now, semantically, there are some differences. Like you can see here that those are float 32s, which is not something you have in JavaScript currently, at least. And then at the bottom, you can see that I'm newing up a class of coordinates, and then I have to explicitly call delete. And that's basically deallocating the actual memory for this. With languages like TurboScript, currently at least, there's no garbage collection. It's more like C++ or C, where you have to deallocate. But this can get you basically where you'd be able to write maybe some performance-centric code in a language that's super familiar to you, but getting all the benefits of that. So when should I target WebAssembly? At least right now, when should you target it? Well, right now it's going to be those heavily CPU-bound number computations, where you're doing things that are heavily computing against numbers. So the quintessential example of that is games, right? But most of us are not game programmers. I know I'm not. So I do want to actually point out a couple things. You're probably, almost every single person in this room is probably already using WebAssembly, and you don't even know it. And that's what's really exciting about this. I'll show you an example here. This is the Mozilla folks. They ported a lot of their code for the source map compilation stuff to Rust. And that Rust then compiles to WebAssembly. And this project is shipping with some of the most popular projects used by our industry. It's used in Babel. It's used in Less. It's used actually in Firefox itself. If you open the developer tools, you're running WebAssembly. And that's really exciting to me. And they wrote a series of articles. When they first did the initial port without doing any optimizations, it was 5.8 or 5.9, yeah, 5.8 times faster. And then with just a little bit of little bit of manual finagling of things, they got up to 10.9 times faster in their parsing. And source map stuff's actually been a major bottleneck for a lot of people when they're doing Babel and they're using their Webpack and stuff like that. So this has been actually a really quick and huge win. If you're familiar with Sass, the Sass community has a C++ compiler for Sass that they rewrote for performance. But every time, if you've ever had to npm install it, it takes forever because it actually has to compile onto your actual machine itself. They don't ship the actual compiled binaries, and it takes forever. And I don't personally like the fact that that I'm downloading from npm this C++ project that just gets arbitrarily compiled and can do whatever it's like. And so there's actually an effort right now to see how big of an effort would it be to compile the Sass compiler from C++ to WebAssembly instead. So that's another very interesting use case. There's a D3 WASM force. If you've used D3, force-directed graph stuff, where it's moving the objects so that they're equidistant between each other and stuff like that. There's a whole bunch of simulations. This stuff was ported to WebAssembly, and it gets a major performance improvement. And these other use cases, I think, are pretty imminent. I think that one of the reasons I'm up here is to try and keep people actually interested in this so that the browsers keep actually investing in this, so that the specification process keeps moving forward. And we're going to touch a little bit on that. But I kind of wanted to pause for a second and actually just kind of circle back. What was that binary stuff that I showed at the beginning, right? The factorial going over to that binary. Well, if you're like me and I open up these hexadecimal things, I mean, I don't like looking at that. I have no idea what's going on. That's not very useful, right? And so binary can be a little intimidating. I want to take a second and just acknowledge that I'm not a wizard. The people who work on this, even the people who do this full time, they're not wizards. They don't just see I don't even see the binary. I just see the code and I see the functions. They're just, I mean, to a certain extent, you recognize some instructions and stuff like that here and there, but no, it doesn't work like that. The pro tip is to just not worry about that. Don't look at the binary. It's not important, unless, of course, you want to. Tooling will eventually make this a complete non-issue. But textual representation is to the rescue. Just like how you don't write machine code by hand, you use assembly language, which is a textual representation. With WebAssembly, if you did want to debug it or you did want to write it by hand, you will use a textual representation. So this is the WebAssembly textual representation of that factorial function, that binary we were looking at. And while it may not be immediately like, oh, I know exactly what's going on, it seems a little more familiar, right? Like you're seeing get local, there's a conditional, you can see the if statement there, right? Okay, that's a little more, okay, maybe I could learn that, maybe. So let's do that right now. Let's learn the fundamentals of what WebAssembly is. So WebAssembly is a stack machine language. So instead of going through those instructions like you would assembly, top to bottom, executing them like that, it actually pushes and pops on a stack machine. Well, what's a stack machine, right? Well, let's first take a look at what a stack is. And you may be thinking to yourself, I know what a stack is, and if you do, awesome. But I just want to cover this so that everyone is on the exact same page. A stack is a data structure in which there is two operations. We can push or we can pop, and that's it. You cannot go into the middle of the stack and be like, I'm going to take something in the middle or what have you. Once you put it on the stack, you have to pop it off. So let's look at a really quick visualization of that. If we've got an item, we want to put that on the stack, we push it. If we've got another item, push that on the stack. One more. Great, now we've got our stack and it's full. Well, what do we want to do? What if I want to get to the bottom item, right? The third item, that first item we pushed onto the stack. Well, to get there, I have to pop. I can't just grab the thing from the bottom. So we're going to pop, and then we're going to pop, and one more. Great. So they're said to have last in, first out semantics. So that's a stack, but what is a stack machine? Well, it's actually pretty simple. A stack machine is just a machine in which the instructions are pushed and popped on the stack. So you push an instruction on the stack, and then it gets popped off. So let's take a look at the most simplest example, 1 plus 2. Every language has this type of expression. So to better dive down to this, we need to learn an instruction. We need to learn the add instruction. And on the right, you have the actual bytecode. And on the left, you have what's called a mnemonic, which is the textual representation that represents that actual instruction. And this is a 32-bit integer add. And there are ones for 64-bit as well, and there's, you can do unsigned and all that stuff. So with that 1 plus 2, it would be a constant of 1, a constant of 2, and then add them. So constant 1, constant 2, add them. With the stack visualization, push that 1 on the stack, push the 2 on the stack, add them. So the add instruction is a magical instruction that just knows that it needs to take 2 operands. It's going to take 2 things off the stack, add them together, and then push the result back onto the stack. So then if you wanted to do something with the result of that, you'd slide an instruction underneath that. So let's say I want to log it out. I would just say call log. And the log is a variable in the textual representation that has to represent a function of some sort that would have to be defined elsewhere in the function in the module. So this is pretty simple, and I hope this helps demystify what WebAssembly is. This is WebAssembly. You're looking at it right now. But if you do end up doing some debugging of this stuff or working on this stuff, you may realize that compilers do a lot of exotic optimization sometimes. So this is the most simplest example in the world, and every compiler in the world is going to do this, right? They're going to know 1 plus 2 is always 3, so I'm not going to defer that to runtime. But the in practice stuff is going to be pretty complex. Going one more step further, there's actually another representation of this textual stuff. It's called an abstract syntax tree representation. If you're familiar with compilers, this is a term that comes from that. And this is just another way of representing the exact same thing that is more easily understood by humans. Because that 1 plus 2 example is pretty simple, but let's imagine you had a value that's really, like you had a huge function, and you had a value that's way up high on the stack. It'd be really hard to trace that, like to mentally understand that all those things get popped off. So this example, we can represent this by sliding in these params. Now, if there's anyone here that, I'm trying to see if there's any fans out here, these are called S expressions, and if they look familiar, it's because it looks like Lisp. And that's because Lisp invented S expressions, 40, 50 years ago or what have you. So this makes it very nested, much more familiar to a normal programmer, where you can see that add takes 2 arguments, and then the call of the log takes that single argument. So this makes it much easier to debug and grok. And all of the tooling that exists in the community is able to represent it this way, to make it easier. So now that you understand the basics of WebAssembly, I do want to take a second and describe what's missing. Like, why is everyone in this room not using WebAssembly? Well, the number one thing in my mind is direct access to the DOM, to those web APIs. So right now, WebAssembly can do a whole bunch of number crunching, but when you want to do anything useful outside of that, you have to call into JavaScript. So if you want to log, or you want to make AJAX requests, or write to the canvas, do anything interesting, you need to call into JavaScript. And that's a problem for a couple reasons. For performance, because you're calling across a bridge, and that bridge it's going to get faster over time, but no matter what, it's always going to have a cost, a penalty. So you need to be able to call those web APIs directly. there's a specification that's being worked on. So that will be that's a stated goal, and that will exist. The kind of related thing is garbage collection. So let's say you do call into one of those DOM APIs. Well, now you've just got back a DOM reference that needs to be garbage collected in some way, right? You could call to JavaScript, give it that reference, or JavaScript could give you that reference, and you now are not able to garbage collect it because you've lost a reference. Like, right, the garbage collector has no knowledge of WebAssembly. So that's another big hang-up that is going to make it a lot better. But also languages like C# and Reason, other languages that are garbage collecting, right now they have to send their own garbage collector with your file. So when you write your application, they have to compile a garbage collector into your application, and that's just extra bytes and performance that you shouldn't need to do, right? You should be able to have a garbage collector that's built into the browser for you. So this is going to be necessary for that JavaScript and what's called WebIDL interop. The next thing that actually is going to be a first in the JavaScript world is true multi-threading. And I'm pretty excited about this. This one's probably going to take a little while to come just because there's so many caveats to it, because you have to be careful when you introduce actual multi-threading. We're not talking about web workers where you're doing serialized message passing and stuff like that. True multi-threading. And it is a stated goal. It's just you got to be careful, because now when you're interacting with JavaScript, you can now start to do very exotic things in JavaScript. Imagine JavaScript calls a WebAssembly method that does something multi-threaded. Now you have race conditions where you can actually call back into JavaScript in parallel and race. So this is pretty exciting, but it's a little ways out, and I think that's really going to make WebAssembly just push it over the edge. So there's a bunch more features that are currently being discussed in the specification group. And I actually want to point out, this is the first time any kind of machine code or bytecode, anything like that, has been standardized across all of the major companies. Microsoft, Google, Mozilla, Apple, they all came together. It's very unprecedented, actually, that this happened. So as I start to close out my talk, I wanted to give a couple examples. We've got Chad here, who's going to be up next. He's very heavy in the Ember community. Are you still on the Ember core team? Yeah, he is. Okay, great. Yeah, so they've been working really hard. Sorry for that tangent, but they've been working really hard actually on rewriting their virtual machine in Rust, and that Rust is going to compile to WebAssembly. And I believe he'll talk a little bit about that here in a bit, and maybe some of the challenges and some of the benefits and stuff like that. So I've been following this pretty closely just because it's the first time anyone's really been doing anything like this. Ember's really pushing that envelope and seeing what's possible today, even with the limitations I talked about. Another thing that's also very attractive, if you're interested in Reason and Reason React, there's a bunch of members of the community who are working really hard to make BuckleScript and those type of things be able to compile to WebAssembly instead of to JavaScript. They're doing some clever things to work around the lack of garbage collection stuff, and so maybe, just maybe, they'll have something ready to be used for production within the next couple of years, but they might wait until the garbage collection is built in. So if you're not familiar, actually I really recommend taking a look at Reason. It's come a huge, long way. You're able to have the best of OCaml with the syntax that's much more familiar to the average JavaScript programmer. And so some really exciting things. So this is all possible right now. You could do these things right now. It's just they have to jump through some hoops, and so there's a lot of development that a lot of people are just kind of waiting. They're waiting for the garbage collection or the WebIDL calling into the direct DOM stuff and stuff like that. So how do I get started today? Let's say you are really excited and you at least want to get your toes wet, or maybe you want to write some Rust and compile the WebAssembly. I recommend starting at webassembly.org. It really is a great resource. There's a lot of stuff that will help you understand fill in the gaps of the things I talked about, and then lead you to other resources and stuff. But there's also a community thing called AwesomeWasm, which has a lot of resources. There's online playgrounds, there's examples, there's different tooling stuff. I know the Rust community in particular has really doubled down on making WebAssembly a first-class thing. If you're curious how compiling C or C++ to WebAssembly looks, well, you use right now a project called mscripton, which handles all of the magic for you under the hood. And it essentially has the exact same API as Clang, if you're familiar with that. So the only difference is you say wasm1, and your output can be either a JavaScript file or an HTML file. If you say HTML, then it'll do all the scaffolding to load up the WebAssembly for you. So the other thing I wanted to touch on is that Webpack has actually added first-class support for this. They received last year a grant from the Mozilla Foundation to do this specifically, to add that support, because they knew that once a bunch of people started using WebAssembly, Webpack is going to be a really great entry point for that. And here's what it would look like. You'd be able to import your Rust file directly with a Rust loader, and it will just automatically compile to WebAssembly and do the linking for you, so it's just magic. And that works today. It's just not quite production ready, in my opinion. So it's getting there, it's getting really close. But as far as the actual support for WebAssembly, all modern browsers today support it. And I emphasize the whole modern, because I did leave Internet Explorer on there, because obviously Internet Explorer is never going to be updated. So that is unfortunate, but people are quickly moving to other browsers like Edge and Chrome and stuff like that. And there are ways and tooling to let you do backwards compatibility type of stuff. You can compile the WebAssembly to JavaScript, and obviously it won't run nearly as good, and there's going to be some issues with that, some caveats, I would say. But it is a doable thing, and people are doing that. So I wanted to finish off by just saying that I really believe that this is a revolution. It is, and it is just beginning. And going back to that little phrase, I actually want to strike out that last part. I want to say efficient low-level bytecode, because there's a joke about WebAssembly that WebAssembly is neither for the web nor is it an assembly language, which is ironic, right? It's called WebAssembly. And the reason why is because the WebAssembly specification, there's not a single line of it that even mentions JavaScript or a browser or a virtual machine. not a virtual machine. It's completely agnostic of that, and a lot of people have actually made note of that because of how great of a language, how great of a bytecode it is. And there's projects like Ethereum, that blockchain, Bitcoin stuff. I don't know anything about that stuff. All I know is that they decided they had this proprietary virtual machine that runs their smart contracts, and instead of having that proprietary thing, now they're moving to WebAssembly. They're having their own WebAssembly virtual machine. And this doesn't run in a browser. This is completely on the server, all that stuff. There's some really exciting use cases about Node, and I'm actually speaking at Node Summit here at the end of July that'll touch specifically on the Node use cases. So if the thing that this is a huge stretch, but I really hope that it happens, is that WebAssembly could be the way that the browser really hooks into the operating system itself. So Android and iOS and all these other platforms, they have their own memory model sandbox, right? How your applications are sandboxed, its own proprietary way. What if they used WebAssembly instead? Right? They have a standardized way of doing the memory model. They have an efficient bytecode, so that way the underlying phones, let's say Apple decides, we no longer want to run ARM, you don't have to recompile your applications just for them to change their processor. There's some really, really cool benefits to these type of things. So I'm hoping in the future people double down on this a lot more. So if you have any questions, you can always reach me on Twitter at _jphelps. The underscore is very important. And thank you so much for listening.
Something that a couple of us were talking about at lunch was this pervasive death of blank attitude about languages and tools and stuff. And when WebAssembly started being talked about, it was like, oh, this is great. This is like, this will push the open web forward. But then, the whole like, will this kill JavaScript?
JavaScript,
yeah.
Yeah.
And it always interested me because, like, one, is it really bad if a language dies? And also, have we ever encountered a language dying before? You know what I mean?
Yeah, great point on the second part. I think that's actually probably the most important point, is that have we really encountered a language dying? Like Python 2.
Yeah, and
so I'm not rooting for JavaScript to die personally. I think JavaScript might be a casualty in some respects, but I'm not rooting for that. I'm just looking at the positives of I'm a big compiler and language nut, so I'm excited for those new languages. Clean slates are always attractive, right? Because you can try again and make totally different mistakes that you didn't make the first time. So I'm excited for that. Like for all the flack that it gets, I really like Dart, and I like what Dart tried to do and still is trying to do, and I just think they just had a bad false start on marketing. I think and direction, I think, a little bit as well. But that's what I'm excited about WebAssembly. It's going to really make that more practical. Because one of the reasons why Dart had a false start is because people would compile the hello world and look at the output. Because you could look at the output, and because it was JavaScript, right? It compiled Dart to JavaScript, and so people would look at the output and go, "Buh, this isn't readable JavaScript," and blah 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 blah. And with WebAssembly. Not only can you have the smaller binary formats and the streaming compilation stuff, but also just there's a lot of optimization things you can do in these low-level binary where you just are basically dealing with numbers. Like a class gets compiled away to just a bunch of loads and stores into memory instead of it being this object thing. And so that's really what I think is. I think if WebAssembly existed back when Dart originally was being made, I think it would have been a different story. I think they would have had a better, and I also don't think that they would have tried to push the whole Dart virtual machine and all that stuff. So I think it would have been better.
Yeah, when you mentioned Dart, my ears perked up. I was like, did he say Dart?
Yeah.
Yeah, no,
when was the last time you heard Dart?
Right.
I follow all the Dart people, so to me it's common. Like I see Dart stuff all the time.
Yeah. So that brings me to sort of back to tech culture. Ellen Ullman is this writer and software engineer who wrote this book, Close to the Machine, and she talked about how, she was running a consulting company around when Java first became a thing, and the developers were like, what is this new Java thing? I don't want to have to deal with this. And also this sort of attitude towards people who worked on newer web stuff versus who were close to the machine, writing assembly. And a lot of the concepts that you brought up, like stacks and stuff, are like computer science 101. Is the culture that we've gotten to now where you don't have to go to college, you don't have to learn theory, is that gonna make a switch as we are getting closer to the machine with web development?
I think if one of the one of the sad things, I don't want to say negative, one of the sad things, because I love WebAssembly so much, is that if the people who are really involved in WebAssembly do their job well, most people in this room won't have to ever touch WebAssembly or even know, not really know anything about WebAssembly itself, because tooling is supposed to make that, a non-issue. And so learning about stacks and CS and all that stuff, I don't think there's going to be an upswing on that. I definitely think that this is very interesting because now for the first real time ever, those two worlds, the native world and the web world are colliding, right? You have native, there was a really funny tweet, I can't quote it, I can't remember what it was, but Qt or Qt, depending on how you want to pronounce it, but there's a project called Qt, the letter Q and then the letter T, that's pretty big in the Linux world for these native applications, the UI stuff. And that group has compiled it to WebAssembly. So you can actually take your Qt apps and compile them and run them in the browser. And a JavaScript person who I follow and respect was like, but why? just so confused, because they're two different worlds, right? They're like, why would you want to run this whole big Chrome, desktop type of app experience in the browser? They're just totally different worlds, and these native people are now having to learn more about JavaScript and the web world, and where a perfect example is file size. Native people haven't really had to care about that, right? It's not uncommon to have 300-400 megabytes in your binary, right? But that would be ridiculous for a web app. So these are now the worlds are colliding, and the problems are having to turn together at the same time. So I think it's really cool because I've done a lot of C and C++ stuff in the past professionally, and then I entered the JavaScript world, and so I see it both, and there's been chuckles. So
yeah, it's very interesting. I think it will bring out a lot of I guess how apparent all of our backgrounds are very different, and hopefully that helps things for the better. Because I used to be a Java developer. I got excited about TypeScript because I love function signatures and stuff. And so WebAssembly is exciting to me because I'm like, cool, I can be a C++ developer again. So within Scripting, you can write C and C++ for the web, and Rust, which is another really super exciting community. If you are on the fence about Rust, get on the right side of the fence because it's such a great community.
It really is a great community. Yeah.
Are there any plans for people who write Java to be able to write it for WebAssembly?
Yes and no. I mean, there isn't as, I would say that community is not as enthusiastic currently. C# stuff, there's actually, there's an experimental work, there's something called Blazor, which is like a UI framework writing in C#. It's a partnership with the Mono team. I don't know if I'm totally off base here, but they actually are compiling to WebAssembly, so it's doable. If C# can go to WebAssembly, Java should have no problem because it's it's actually a simpler language.
Yeah,
but,
it's all an excitement around the communities.
it's all just time and excitement, and a lot, like I was saying before, a lot of them are like looking at it and saying, well, I'm going to wait until it has garbage collection. Like I'm just not going to bother with doing the effort, because it is a huge amount of work for these language developers and compiler people to migrate and be able to compile to WebAssembly and stuff like that. So it's non-trivial, but yeah.
Awesome. Well, thank you so much.
Cool.
Let's give a hand for Jay and WebAssembly.
Cool. Thanks, Jen.